Imagine you are standing near a lake. In one hand you have a small stone. Far away in water there is a giant ship carrying 1,000 of tons of cargo. Now think about it. If you drop a stone into water, it sinks immediately. But the enormous ship keeps floating. How is that possible? The stone is tiny, ship is massive. Shouldn't the heavier object sink first? Well, today we are going to uncover one of the most fascinating secrets of physics. The secret force that allows giant ship to float, and it all begins with simple observation about the water. Leo standing beside the lake. He throws a small stone into the water. Splash. The stone sinks. Leo look at the huge ship floating nearby. Wait a second. If a stone sinks, why doesn't ship sink too? Is water somehow stronger under the ship, or is there invisible force helping it float? Let's investigate. Remember what we learned in previous video? Water exerts pressure in every direction. Not just downward, not just sideways, every direction. Now imagine placing a block completely underwater. Water pushes on the top of the block, water also pushes on the bottom. At first it might seem that these two forces should be equal, but are they? Think carefully. The bottom of the block is deeper than the top, and we already know something very important. Pressure increases with that. So water pushing on the bottom experience greater pressure than the water pushing on the top. That's mean the upward force on the bottom is larger than the downward force on the top. And whenever one force is larger than the another, a net force appear. In this case, a net upward force. Water is actually pushing the object upward. This upward force is called buoyant force. This is the first big idea. Water doesn't simply hold the object. Water actively pushes them upward. Every object placed in water experiences an upward buoyant force. Whether it is a stone, wooden block, a submarine, or a giant ship, water is always trying to push object upward. But then a question appears. If water pushes everything upward, why do some bodies still sink? To answer that, we need to meet a brilliant scientist. More than 2000 years ago, a Greek scientist named Archimedes was studying object in water. One day he noticed something interesting. Whenever an object enters water, the water level rises. Why? Because the object takes up space. It pushes some water out of the way. This is called displacement. The object displaces water. The larger the object, more water it displaces. And Archimedes discovers something remarkable. The upward buoyant force acting on an object is exactly equal to the weight of the water displaced by that object. This idea becomes known as Archimedes Principle. A simple statement of principle is the buoyant force on an object equal to the weight of the fluid displaced by it. The single idea explains floating, sinking, ship, submarine, and much more. Let's return to our stone. Two forces act on it. First, gravity pull it stone downward, and this is stone's weight. Second, water pushes stone upward with buoyant force. Now compare these forces. For a stone, the weight is larger than the buoyant force. Gravity wins, and the stone moves downward and it sinks. So stone sinks because weight is greater than the upward push provided by water. Now let's look at ship. At a first glance, this seems impossible. Ships are made mostly of steel, and steel sink in water. So why doesn't ship sink? The answer is shape. A ship is not solid block of steel. Most of its interior is hollow. This hollow design gives a ship a very large volume. As a ship enters in water, it displaces huge amount of water. More displaced water means large buoyant force. Eventually, buoyant force become equal to the ship weight. At the moment the force balance, the ship neither sink nor rises. It floats. That's the secret. Ship floats not because they are light. Ship floats because they shaped enough to water to create a buoyant force equal to their weight. Imagine taking a solid block of steel, drop it into water, it sinks. Now reshape the same steel into form of a boat. Suddenly it floats. Did the amount of steel change? No. Did the weight change? No. The shape change. The volume increases. More water displaced. The buoyant force becomes large enough to support the weight, and the boat floats. Let's summarize everything we learned. Water pressure increased with that. Because of this, the bottom of an object experiences greater force than the top. This creates an upward force called buoyant force. Every object in water experiences buoyancy. If a weight is greater than the buoyant force, the object sinks. A buoyant force equal to the weight, the object is float. And thanks to the Archimedes principle, we know that the buoyant force depends on the amount water displaced. That's why tiny stone sinks and giant ship floats. The next time you see a ship crossing the ocean, remember, it's not floating because it's light. It's floating because water is pushing it upward with an enormous buoyant force. And that's the beautiful physics of Archimedes principle. Don't memorize it, visualize it.